Sometimes, when given an integral, we can make a substitution which allows us to express this integral as a rational function. And then, of course, theoretically, we should be able to integrate the rational function using the techniques we've just discussed of partial fractions. Let's look at an example, the integral of the square root of x over x plus 1 dx. We're going to try the substitution u equals the square root of x, but it's not immediately obvious that this is going to work. Our first step is to calculate du, and this is 1 over 2 times the square root of x dx. Notice that everything here except for the dx can be expressed in terms of u. So du is 1 over 2u dx. If I multiply this by 2u, I get dx can be replaced by 2u du in this integral. And everything else can also be expressed in terms of u, so therefore I can complete this substitution. We have the square root of x can be replaced by u, x itself can be replaced by u squared, and dx can be replaced by 2u du. So our integral becomes the integral of 2u squared over u squared plus 1 du. Now this is a rational function. It's not a proper rational function, so I first have to use long division. We get 2u squared is 2 times u squared plus 1 minus a remainder of 2. And of course this means 2u squared over u squared plus 1 is 2 minus 2 over u squared plus 1. Now the integral of 2u squared over u squared plus 1 du is the integral of the right-hand side here, which is the integral of 2 minus the integral of the proper rational function 2 over u squared plus 1. But these are both relatively easy at this point. The integral of 2 is 2u, and the integral of 2 times u squared plus 1 is 2 times tan inverse u plus a constant. And now, converting back to our x's, we get that the integral of the square root of x over x plus 1 dx is 2 times the square root of x minus 2 times tan inverse of the square root of x plus a constant.